This lesson is about data manipulation mostly with pandas. Pandas has a lot of useful functions to help us manipulate data, and we're going to take advantage of some of those here. There's really no limit to what you can do as far as data management and manipulation and analysis, and we've only selected a sampling here, so if you choose to go beyond what we were offering in this lesson, you could go ahead and look at the documentation. I've also embedded several links within these notes that contain pretty nice examples that I wanted to share with you. If you find one that's really good, go ahead and share it with the class, maybe on Slack. That would be great. So we'll start by importing some data that we'll work with throughout this lesson. And that data comes from Gapminder, which is a great resource for global data on all sorts of indicators, but what we'll be looking at is sort of the classic life expectancy, GDP, and population data for countries of the world over a period of time. You'll see that the nature of the data set is actually perfect because it allows us to do a lot of different things to change the data, take subsets of the data, and make modifications to suit our needs. So in the notes we have two different suggestions for how to import the data. Just in case one doesn't work, we could try the other. In order to use the Gapminder library, you would have to first install Gapminder using this line right here that I've commented out, because this only has to be done once. So once you've run this, you can comment it out and you don't have to run it anymore. So I'm going to import Gapminder from Gapminder, and I'm going to import pandas with the alias PD. And I'm going to take a look at the first couple of rows. And there we go. Again, you could also try this with the URL, which is here. And if you click the URL, you'll see this data. It's in comma separated value form, CSV. So that's good because we can read it in. Take a look at the endpoint of the URL. It's actually a file with a CSV extension. So we can use then the read CSV and then reference the data URL, which I've stored as a variable here. So either method is going to work. We just need to make sure that we have a data set called GM, and we'll want to keep that name, and when we create subsets of this data set, we'll want to give them different names so we don't end up confusing ourselves. All right, so as you can see, the data has measurements every 5-year increments on the same country. So that may pose some problems for us when we want to take a statistical summary of the entire data set. So this is not a good choice, but I'm going to illustrate it anyway to show why it really doesn't make sense. So here I'm looking at, this is looking at the statistical summary of the data, and it's giving me some values, especially the population, that actually don't make a whole lot of sense for averages, for example. So it's going to make more sense for us to specify a single year at a time and filter out that year, and then conduct a statistical summary within that new data frame that we create. So that brings us to filtering. It's a pretty natural next step here once we've imported the data. If we want the most recent data, we can find out the maximum year. I can also look at my summary, it's because it is going to tell me the maximum year is 2007. That's the last data point we have in terms of year, so I could also use the max function as you see here. This next line I want to break down real quick, piece by piece. What this is doing is setting a new variable called GM07 and setting it equal to a statement that takes from the overall Gapminder data frame, and then from within that, we're setting up a Boolean value. So this Boolean value set is going to allow us to check if the year is equal to 2007. So I say take from the Gapminder data frame the Gapminder values such that the year is equal to 2007. So then I can reference that entire column as GM07, and I can also take a look at it. I'm printing, but I think I want to look at the nicer, tidier form, and I'll do this. So print gives me the dimensions, print the shape gives me the dimensions. So I have 142 rows and 6 columns. All right, and then here's the top part of the data set, and notice that all the years are 2007. Now it might make more sense for us to do a statistical summary of all the countries of the world based on a single year. So we remove that variability due to year and focus only on the variability by country, which is a better practice statistically. So here we go. Okay, so we have our count, mean, standard deviation, minimum, our 5-number summary. Notice 50%, that's going to be the median. So 50th percentile is the median. Notice the difference between the median and the mean for life expectancy. They're kind of far apart considering we have so many values. This is reflecting the skewed nature of the distribution. When we're at the beginning of a data analysis, it's helpful to do a little bit of data exploration visually. Now, next class is entirely focused on data visualization, and we'll get much better at it, and we'll use the Matplotlib library, and especially the module called PyPlot from within that. That gives us a number of plots we can use. But today we're just going to look at some of them, and we'll ignore that the scales and labels don't look very nice, because that's not really what today is about. Also want to point out the percent matplotlib inline. This is something we have to do to run to actually display our plots in this browser that we have open. The browser is running our Python code in the form of a Jupyter notebook, so sometimes we have to use a few tricks to make it work. I can run that code, there's not going to be any output, but it's going to set me up nicely to create plots that I can actually see. So let's choose a histogram, because a histogram is going to show us some detail about the distribution. And here we go. So no labels at this point, but we really just care about the shape, and we know that this is about life expectancy. I would never recommend putting a graph like this in a report because it has no labels, and that's terrible. But this is just for our own purposes. We see that the distribution is skewed. We would call that skewed to the left. The tail's on the left. The peak is on the right. And that also kind of looks bimodal. It looks like there's a collection of countries with a lower average life expectancy, and then another collection of countries with a higher life expectancy. Quite a few more. So those high life expectancy countries are much more concentrated in a smaller range of values. That's important. We're going to see the same pattern if we look at GDP, but in the other direction, which kind of makes sense because these two variables are, I would say, opposite in the way that they measure the health of a country, right? So this is right skewed and appears to have an emerging bimodal pattern with two peaks around these, maybe below 10,000 and then somewhere above 30,000, yeah, right there. Okay, so this is just going to tell us that if we are to use a measure of central tendency, it makes sense to use a median because the mean is going to be impacted by this skewed nature of the distribution. Okay, so that's a summary of filtering and a little bit of an overview, and a look at some methods we can use with data that have been filtered. next you're going to have an exercise to try.